Before we have constructed confidence interval for population mean when sigma is known. In that case, we use z-test, so-called z formula, z alpha by 2 sigma over square root of n. But now we are constructing confidence interval for population mean when sigma is unknown. So when sigma is unknown, in that case, we used to apply t-test like x bar plus minus t alpha by 2 s over, and you can see clearly the difference between two formulas. When sigma is known, then x bar plus minus z alpha by 2 times sigma over square root of n. But when sigma is known, in that case we apply t-test. And in real life problem, normally we don't know what is population standard deviation, because if we know population standard deviation, it means that we know population mean, and if we know population mean, which is mu, then there is no need to estimate it. So to know sigma, we must know mean, so there is no need to do all these tests. So in real life, normally we don't know what is sigma. So when sigma is unknown, we apply t-test and we use s as a standard deviation which comes from sample. We draw a sample, we calculate its mean, sample mean, and we calculate its sample standard deviation, and we use it in the formula, and that is why our formula becomes x bar plus minus t alpha by 2 degree of freedom, which is n minus 1 times s. Here instead of s, before we were using population standard deviation. If the population standard deviation sigma is unknown, this is very important statement, if the population standard deviation sigma is unknown, we can substitute the sample standard deviation n instead of sigma. I repeat my statement: plus minus t alpha by 2 n minus 1 times over square root of n. If population standard deviation sigma, this sigma is unknown, so we substitute the sample standard deviation s here instead of this sigma. This introduces extra uncertainty since s is variable from sample to sample, because every sample has different standard deviation and mean. Okay, so there are some assumptions which we consider in this calculation. Population standard deviation is unknown. We assume that population standard deviation is unknown. Population is normally distributed. We take this assumption almost in every case, and we use students t distribution, and its formula is this one. So its formula is x bar plus minus t alpha by 2 degree of freedom n minus 1, n is sample size, n will be given, right? This. Okay, if t is a family distribution, the t alpha by 2 values depend upon the degree of freedom. Degree of freedom is n minus 1. I have already explained it. So what is degree of freedom? We don't need to go into this discussion because it is not important to know, but you can just see that degree of freedom is n minus 1. For example, if your sample size n is 25, so your degree of freedom will become 25 minus 1, 24. Okay, so here you can see that how can we see the value in the table. For example, if alpha is 5%, then alpha by 2 will become 2.5%, which is 0.025. So alpha by 2 is 0.025, and let's say n is given, sample size is 24, then degree of freedom will become 25 minus 1, which is 24. So we see where is 0.025 in the table. Here you can see 0.025 in the table and we see where is 24. Let's say it is continuous, here it is 24, so whatever number you will see here would be your degree of freedom. But in this case our n is 3, so degree of freedom you can see is 2, and alpha by 2 is 0.05, so this is our degree of freedom in that case. So here you can see some degree of freedoms for different level of confidence, and if n is sufficiently large, t distribution approaches to z distribution, because normally t distribution is for small sample size. We solve one simple example. A random sample of n25 and x bar is 50 and s is 8. You are given s not sigma. So from here we came to know that sigma is unknown. So we use sample standard deviation form in 95% confidence interval. Degree of freedom is n minus 1, n is 25, so degree of freedom is 24. T alpha by 2 is alpha 95% confidence interval, so alpha is remaining 5%, so alpha by 2 t 0.025 corresponding to 24. In the table, in the t table back of your book, you will see 0.025, and here it is degree of freedom 1 2 3 up till so on. Here you can see somewhere true at 24, and this value would be 2.0639 in the table. So this value comes from the table t table. Rest is nothing, you can simply substitute the values and you can get the confidence interval for this. Okay. So confidence, we developed confidence interval for two cases. When sigma is known, then we use to apply z, and when sigma is unknown, then we apply t test or confidence interval for t.